So today we're gonna talk about exponential functions. Um, so let me start by giving the definition of exponential function. So an exponential function is a function which looks like this. So fx is equal to b to power x. So every function which looks like this is called an exponential function. So where um, b is just some number, b is a constant. We're going to assume always for our purposes b is going to be positive in this case, but sometimes it could be negative as well. Actually, let me see. So it's not necessarily, yeah, we're going to say that b is a positive number and also b is not equal to 1. Okay, and the reason we do b not equal to 1 is because if I take b equals 1, it becomes 1 to power x, and 1 to any number is 1, so it becomes a constant function. But this, for all the other numbers, it's not a constant function. Okay, so this is called this function is called an exponential function with base b, and x is called exponent. Exponent x. Okay, so that's called the exponential function with base is this number b here, and exponent is whatever you have in the power. Okay, so there is a difference between exponential functions and power functions. So we talked about power functions quite a bit, so let me just remind you and so that you can see the difference. So I'm just going to write it here. So power function, so they look like this, right? So it was y equals x to some power n, right? So in the difference in this case is that the power is fixed and the base, so this is the power and this is the base. So for the power function, the power is a fixed number, it's not changing. And for the exponential function, the exponent is changing, right? So the exponent is changing, but the base is a fixed number. So that's the difference. So let me give you couple of examples of exponential functions. So so in example is, let's take b equals 2. Then I have fx equals 2 to power x. Okay, so that's an example of an exponential function. This is an exponential function with base equals to 2. So let's take some numbers and plug into x instead of x. Okay, so if fx equals 2 to the x, then sorry, then I have that f, for instance, of 0 is equal to 2 to power 0, right? And 2 to power 0 is 1. Or I can take f to power any number. It doesn't have to be positive or negative. So let's pick a positive number, 1. and I get 2 to power 1, that's 2. If I take f to power 3, f3 is 2 to power 3, which is 8, right? And so, or I can take a negative number. I can take f of negative 1. That would be 2 to power negative 1, which is 1 half, or if you want 0.5. And then if I take f, for instance, negative 3, or negative, let's do negative 2, that's 2 to power negative 2, or 1 over 2 to power 2, so that's 1 over 4, right? Or 0.25. Okay, so those are some examples. So in this case, for instance, I can try to plot some of these numbers. So let's see what are the numbers. At 0 I have 1, at 1 I have 2, at negative 1 I have 0.5. So if I was to plot this function here, I would get something which looks like this. So at 0, right, so at 0 I'm going to draw the function with a red, so it's going, so at this point 0, 1, 2, 3, 4, etc. And then I have negative 1, negative 2, negative 3. So at 0 the function is equal to 1, right? Here, f at 0 is equal to 1. F at 1, that's 2 to power 1 is 2. So here, so let's actually draw these numbers, 2, 3, 4, and so on. So at 0, it's equal to 1. At 1, it's equal to 2. So I'm going to draw it here. Oops. Right? At 2, it's equal to 4. Okay? So at so let me actually write that down again. So I have that 2 to power 0 is equal to 1, 2 to power 1 is equal to 2, 2 to power 2 is equal to 4, and 2 to power 3 is equal to 8, right? We know that. And then for negative numbers, we would have 2 to power negative 1 is equal to 1 half, or 0.5. And then 2 to power negative 2, it's 1 over 2 to power 2, which is 1 quarter, 0.25. Okay, and so on. So the picture looks like this. So at 0 I have 1, at 1 I get 2, at 2 I'll get 4, and at 8, at 3 I have to get 8, which is not in this picture anymore. So I can't draw. It goes fast, it goes really high really fast. And then if I do negative numbers, so like here, 2 negative 1, so at negative 1 my answer is going to be 0.5, so that's somewhere here. So let's draw that. That's half. And then I have a negative 2 to power negative 2. That gives you 1 quarter. So that's somewhere here. So now let me try to connect these points. And if I try to do that, I'm going to get a curve which kind of looks like this. Okay. So that's a curve which looks like that. And so for negative numbers, it becomes really small really fast, and for positive numbers it becomes really big really fast. So it's a function which goes really fast when x becomes really large, and it becomes really small when x becomes a negative number. Okay, so that's my x and that's my y, and this is the graph of y equals 2 to the x. Okay, so similarly, I could have drawn different examples. I could have drawn the function y equals 3 to the x, right? Or I could have done y equals, instead of not larger number, like I can take something between 1 and 2. So for instance, 1.5x. I could do y equals 1 half 1 to power x, but that's the same thing as 1, because 1 to every power is x, is 1 again. And then I could have taken also y equals negative, say, 2x, right? So, or if you want, 1 over 2x, 1 over 2 to power x. So I'll get different kind of functions. So let me draw for you how these functions would look like on a different page. So, okay, so I'm gonna try to copy this one here, and on the same graph, I'm gonna try to draw all the other examples as well. Copy. Actually, I'll put it right here. Okay. Okay, so that's 2 to the x. So if I wanted to draw 3 to the x, I'll use a different color here, this one here. Oops. So 3 to the x would look like this. So it would have to go through that point, and then it could go further up, and then here it would go through a smaller point, but it would also go through this 1 point. So it would look like this.
Um, I have a question.
Yes.
Um, for like the equation you just showed at the bottom, y equals 3x. My
Uh-huh.
eye kind of got messed up. I'm confused. How did you get that? If you have time to explain that to me.
So those are all different kind of exponential functions you can have. So if you remember on the previous page, I drew here that your exponential function is any function which looks like this.
Mm-hmm.
So b can be any number. One example is 2 to power x. That's what I drew with the blue. Okay.
So
Now I'm trying
it
to give
has to
you
be greater than 0.
what?
It
Yes,
has.
b has to be greater than 0. That's important.
Okay, okay, okay.
So then here is another example. So this green one is something like, oops,
Because I'm actually focused.
good job.
Oh,
Okay, so three, oops.
Wait, why does b have to be greater than 0 though? It can't be negatives?
I'll tell you in a second.
Okay.
So this is 3 to the x. Let me do the 2 to the x.
wait. So one last thing.
Yes, yes.
Y equals 1 comma 5x. What is that?
That means, sorry, I should have written this way. What I meant is this is in parentheses, 1.5 to power x.
Oh, I thought it was a comma. All right, all right, all right.
1.5, oh yeah, that's not, that's a dot, right?
Okay, yes, sir, yes, sir. Yes, sir.
Okay, so then 1 to power x, of course, would look like this. So I can draw it for you as a straight line. Okay, this is 1 to power x. And so I could also do so I could also do 1.5 to power x. So that's gonna, let's try to do different color. Let's do pink. Okay, so the pink 1.5, it would have to look like this. Okay, so the point is that as long as this base is a number that's greater than 1, the function is increasing very fast. However, if I do 1 over 2 to power x and try to draw that, that would look the opposite. So if you try to do 1 over, let's take a different color here. Let's take this purple one. So 1 over 2 to the x would look kind of the opposite of the blue one. So it would be like this. So it would be 1 half here, it would be 2 here, and then it would be 4 here, and so on. So the picture would look like this. So that would be an example of a function with base less than 1. So it's, if you want, I can write either 1 over 2 or 0.5 to power x. Okay, so is that clear? So the point is that these are all examples of exponential functions, and you probably you have heard about of the term exponential growth, right? So the reason people talk about exponential growth is that exponential functions, this 3 to power x, 2 to power x, or 1.5 to power x, they are functions which grow really, really fast. Like for instance, in this case, see, it took just the point all to go to 1, right? So 1, it becomes 2, then at 2 this function becomes 4, at 3 it becomes 8, so I can't really draw it anymore. If I was to draw it, this would go really fast here. It would basically be here, so it would double in time. So it's like the graph is almost vertical, right? So that's the point this of the exponential growth. So example again, so what it, in other words, what it means that in the function, for instance, 2 to the x, in every unit of time it doubles, right? So if you've been following this coronavirus thing, is like how much time it takes for something to double. So this function 2 to the x, it takes 1 unit of time to double, right? And then it becomes really fast, really big, really fast. And then similarly, 3 to the x, it takes 1 unit of time to triple. Okay, so it becomes 3 times big at every step. So that's, these kind of functions are very fast growing. On the other hand, if you look 0.5x, this purple curve, right? So the purple curve, it becomes small really fast, and that's something that's called exponential decay. Something becomes small really fast, so becomes half of the size. For instance, when you try to inject someone medicine, what you expect is that medicine would kill the virus or something very fast, and in the unit amount of time, the number of the bad cells would go down and becomes half in 1 unit of time, and then half, 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 and so on. Okay, so these are examples of
Nigga always
exponential
gonna bring that shit
functions.
up, yo.
Some of them are
Niggas
exponentially
bro.
increasing, some of them are exponentially
Like
decreasing,
bro.
decaying.
Honestly, it wasn't really a dumb question.
Uh,
Honestly, like,
Professor,
Hello?
yeah, Professor, I had
what?
a question.
Yes.
For 0.5 to the x. So basically, if it's less than 1, it looks like kind of an inverse relationship.
Right.
Is
So as soon as, so let me write it like this. So you're right. So if b is greater than 1, then it's increasing. I don't, and increasing, and b less than 1 is decreasing, right? And b equals to 1, it's the constant. 1 equals x is just 1, right? So that's where everything changes. Okay. Okay, so those are the different kinds. So, but before we go on, I want to remind you some laws, some algebraic laws, which we will use all the time. So when dealing with exponentials, so laws of exponents. So let's write that. So laws of exponents. Okay, so number one, so bx times by. These are some things that you probably have used all the time. So when you multiply two exponentials, then the powers add up, right? So then you have uh, the ratio bx over by is equal to b to power x minus y, 3 bx to power y. We've done this also for power functions, if you remember. If you take the power of a power, then the powers multiply. Then 4, if you have two bases, you multiply and raise it to the same power, then that's the same as multiplying the exponentials, right? So if you have that, so and then number 5 is the same thing but with a ratio. A divided by b to power x is ax over bx. Okay, so those are the rules which we will be using for the examples, for these examples that we do next. Okay. Okay, so let's do some calculations.
This is sort of like pre-calculus, right?
Well, it is, but I mean, we're going to use it for compound interest there. I mean, I'm kind of skipping the calculus part of it. I'm not going to tell you. I mean, we were supposed to cover the derivatives on log of exponentials, but I'm not going to talk about that. We don't have the time. Okay, so we're going to evaluate these expressions. So let's start with this. So it's 3 to power negative 3 times 3 to power 5. So
I'm tremendously sorry, but could you go back real quick? Could you go back
which part?
where you were just at? You know what I
This
mean?
one?
Yeah, right there, right there, right there.
Okay.
All right, hold on, man. I don't want to hold up the lesson plan.
Is that good?
Hold on. I'm on the last few words. Not taking. Wait. Do we have one more class after this? This is the
We
last.
have 2 more classes, and then there will be a review session on Thursday next week, and then there will be a final on Friday.
All right, yes, sir. All right, yes, sir. Thank you. You could go back to work.
Okay, so I'm gonna be using these things. So actually, let me remove this page. How do I remove this page? Okay, I'll do it later. Okay, so we're gonna use these rules to deal with this problem. So now I have what? 3 to power negative 3 times 3 to power 5. So what I do is I add the powers, right? So it's going to be 3 to power negative 3 plus 5. So it's 3 to power negative 3 plus 5 is 2. So the answer is 9. Okay. Okay, so this is the same thing. I don't know why I have a gx here. This is not gx. This is equal to 2 to power negative 3 plus 6. So it's 2 to power 3. So it's just 8. Okay. And this one here is, okay, so this is a little different. We take power of a power, and when we do that, the powers multiply, right? So I'm gonna get negative 1/3 to power 3 times negative 2. So that's going to be negative 1/3 to power 3 times negative 2 is negative 6, right? Now I'm going to simplify this. If I raise it to power negative 6, it's the same thing as taking the reciprocal and raising it to power 6. So it's going to be 1 over negative 1 over 3 to power 6, right? Okay, so or if you want it, I could have written it even like this, to power 6. 1 over the base to power
Excuse
6.
me. Sorry.
Yes,
Do you think you could go back to the previous slide one last time? Just really briefly, really briefly.
this one.
Okay, thank you so much. Just give me 1 second. Give me 1 second.
Okay,
Give me 1 second. It's not gonna take too long.
yeah.
All right, thank you so much, sir. Thank you
Mm-hmm.
so much.
Yeah. Okay. So we're doing this problem here. So now this gives me what? So I'm gonna do the inside here first. The inside is 1 over negative 1/3. So if I do the fractions, it becomes negative to negative 3. So inside of the parentheses, I get negative 3, right? Because 1 divided by negative 1/3 is negative 3. So I'm going to raise that to power 6. Okay. Now I'm raising negative 3 to power 6. 6 is an even number, so when I raise something to an even number, it's always going to be positive, right? It's like squaring, right? So it's the same thing. So it's the same as 3 to power 6. I can write it as either 3 to power 6 or whatever you want. I mean, if you have a calculator, you can write it out.
Quick
I don't
question.
know. Yes?
And
729.
it
That's
might have
729.
Yes,
Did you
729.
did you do it on your in your mind?
No, I did it
Oh,
through
oh,
this.
okay, yeah.
Oh, sir. You see where it says negative 1/3 to the power of negative 6?
yeah.
Right.
Okay, so couldn't we use the rule like a over b to the power x?
Yeah, you could
So
actually.
that means like what you raise the 1 and the 3 to the negative 6? Could you do that?
Right. So what you would do is then you would write. Okay, so we have to take care of the negative sign first, right? But then
It's too complicated.
Speak.
I think it's easier this way.
Okay.
But I don't know. You can try and see which one's easier for you. Okay, so I'm gonna go to the next one. It's similar. So this is negative 1/4. So now see I have again power and then another power. So power of a power. When you do that, you multiply the powers. So it's going to be 2 times negative 3. So it's negative 1/4 to power negative 6. And then just like in the previous problem, I'm going to write the negative 1/4 to power negative 6 is the same thing as negative 4 to power 6, right? because I take the reciprocal and raise it to power 6. And again, it's the same thing as, if you want, I can write it actually differently, but the point is, it's because the power is even, I get rid of the negative sign. Or if you want, I can write negative 4 as negative 1 times 4, right? So negative 1 times 4 to power 6. That's too many details maybe, but that's telling you that it's equal to negative 1 to power 6
Wait,
times 4 to power 6. Yes?
repeat that last
Yo,
part.
yo, don't tell me to shut up, bro. What I tell you about telling me to shut up, bro? Like you always be whining, like you be bugging.
Who's he talking to?
Hello?
Sorry, I don't know what that student was doing, but anyways, when you do like, because I didn't catch this before. I know somebody asked it before. I'm sorry, but when you do negative 1/4
Right.
1/4 to the -6 power, can't
Uh-huh.
you put that whole 1/4 negative under one, like turn it into a fraction? But like, why are you just? I don't know how you're jumping from that to -4 to the 6 power. Maybe I wasn't
Right.
right.
So what I do is, see, like this. So if I had 1 over 4 to power negative 1, what is this?
This is 1/4. What?
Which is? Which is 4, right? 1 over 1 over 4,
That's 4.
which is 4.
Oh, okay. That makes perfect sense. All right, thank you.
But that's why I'm doing this.
All right, thank you.
Hmm.
Got it.
Right. Okay. So continuing with this, here, what we got is just the answer is 4 to power 6, right? Because this part here is 1. You take negative 2, that's just 1. So the whole thing is becoming 4 to power 6. And again, you can leave it like this, or you can use a calculator. If you use a calculator, I believe it's going to be 4,000 and something. Yeah, just leave this like that. I think it's fine. Okay, so this thing is, next one is this one here. So here we have to do a little bit thinking. So here, see, we're multiplying. So what we want to do is we want to write this as a single exponential. So meaning we have to write that we have what? Here two terms which look very different. So this term here and this term here. So here we have to note that 36 is, just remember that 36 is just 6 squared, right? So we're just going to use that. If we do that, then the expression is going to be simplified quite a bit. So let me do that. So if I write 6 to power 1/4, then instead of 36, I'm going to write 6 squared and then raise that to this power negative 5 over 8. Okay, so that's the only thing I'm doing here. So just write 36 as 6 squared. And then, so if I do that, then I keep the 6 to power 1/4 as it is, and then multiply 6 squared to power negative 5/8. Well, this is the power of a power, right? So the powers multiply, so I get negative 5/8 times 2. So it's going to be 2 times negative 5/8, right? So that's going to be 6 to power 1/4 times 6 to power negative 5/8 times 2. Well, 2 and 8 cancel, they give me a 4. So it's going to be negative 5/4. Okay. So then So, but now I have what? I have the same base in these both cases, but the powers are different. So that means I have to add the powers, exponents, right? So it's going to be 6 to power 1/4 minus 5/4.
We always have to make the bases the same in order to then add the x.
Well, yeah, if you want to add the powers, the exponents, then the base has to be the same.
Is there another way to do this, or
I don't think so.
no? Okay.
Yeah. So this is going to be then 6 to power 1/4 minus 5/4 is negative 4/4, right? So it's going to be negative. So if you do the fraction, it's going to be 4, 1 minus 5. So it's just negative 4 over 4. So it's negative 1. 6 to power negative 4 over 4, which is negative 1.
Listen, listen.
Question. So this is 1/6. So that's your answer. Or this one here, doesn't matter. Okay. So similarly for this example here, I have 7 to some power times 49 to another power. We want to simplify this. And again, to do that, we're going to just recall that 49 is 7 squared. So I'm just going to do that. So I'm going to write that this is equal to 7 to power 3/4 times 49 is 7 squared to power negative 3/2. So it's 7 to power 3/4 times 7. Now again, I have what? I have a power of a power, right? So the powers multiply. So I get 7, 2 times negative 3/2. 2 times negative 3/2. And then, of course, these 2 and these 2 cancel. And then I have all I have is 7 to power negative 3 for the second term. So I have 7 to power 3/4 times 7 to power negative 3. So now the bases are the same, so I can add the powers or the exponents. So it's going to be 7 to power 3/4 minus 3. So if I write it out, it's going to be 7 to power base. Here I have 4, 3 minus 12, right? So it's negative 9 over 4. Okay, and we can leave the answer like that. So
Simplify it further, like do 1 over 7 to
you could. I mean, we can simplify in many different ways. For instance, 9 over 4 is equal to 2.25. So you can write 7 to power negative 2.25, or you can write 1 over 7 to power 2.25. But any of those answers would be okay. So you can leave it like this, or you can write it like this. You can write 1 over 7 to power 9/4, right? And also you can write 1 over 7 2.25. Any of these answers would be okay. Okay, so so these are just basic arithmetic problems, just to brush you up on exponents and bases. So the next ones are, we're doing the same thing with functional form. So if you have something like a constant times x to some power. We want to simplify it. I mean, we've done these things when we were doing the uh, we were dealing with the power functions, right? So let's just do these examples as well. Okay, so we want to simplify this expression. We're gonna get 3 times x squared. Now I'm gonna separate -6, and actually let me just do it this way. So I'm gonna combine the constant terms, this one here and this one here. So it's going to be 3 times -6, okay? So 3 times -6, and then I'm gonna multiply x to power 3 times x to power -2. So x to power 3 times x to power -2.
Hold on. I just noticed something. One little problem. Wait, the problems we were doing before, they weren't multiplication? The
They
example,
were right, yeah. Some of this here, they're multiplication.
like the ones, yeah, they're all multiplication. So what's the x makes the difference now, right?
Yeah, the x makes the difference.
They're like common. Okay, okay, okay. Go back to what you were doing. Thank you. Good man.
So we're gonna get 3 times -6 is -18 times, and then the powers here of course add up, so you get x to power 3 minus 2, which is 1. Okay, so that's the answer here. And so let's do similarly the last the next one here. So I get this is 6 times -7 times x to power -3 times x to power -9, and so that gives me 6 times -7 is -42 times x to power -3 minus 9, so that's -42 times x to power -12. Okay, so these are basic products of things like these are mostly power functions, not exponential functions.
-9?
What?
How'd you get -9? It shows +9.
Oh, sorry, I didn't. I just read it wrong.
Yeah. So it should be, I think, to
So
the
this
same.
is positive, right? Positive, so it's going to be. So it's going to be 6. Right. Thank you. Okay, so that's that. So those just simple things, just to remind you how to deal with uh, exponents. And here are, let's see, some more examples, very easy ones here. So this one here is telling you that you have x to power r over s, and you're raising it to power s over r. So we just have power of a power, so powers multiply. So I have x to power r over s times s over r, right? But in this case, everything cancels. This cancels that, and this cancels this, so you get what? 1. So you get that this is equal to x to power 1, which is just x. Okay? And similarly for this other example, it's the same thing. Uh, I have x to power negative b over a times negative a over b. Okay, and again, everything cancels. This cancels that, this cancels that. So you just have, and then negative and negative, of course, also cancel. So you get x to power 1, which is just x. Okay, no, this is not the derivative, it's just uh, first power. Okay, and so let's do one more kind of example that we'll be using. So this is an equation we have to solve, and that's going to be useful later. So here we have two exponential things, two exponentials that are equal to each other, and you have to solve for x here. But the point is that if the bases are the same, then the exponentials are the same when the exponents are the same. So all you have to do is you have to set this equal to that and solve. Okay, so let's do that. So this gives you that this is equal. So how do you solve this? You just write 2x. So 2x minus 4 is equal to -2. Okay, so if I solve this, I'm gonna add both sides, 4 to both sides, so I'm gonna get 2x. There is no more 4 here, so I'll have -2 plus 4. So it's 2x equals to 2. So yeah, 2. So x equals 1.
Okay.
Okay. So, and the next one here is a more interesting example. So we have this thing. It doesn't look like you have the bases are the same. So if you want to solve, you better write these things, the left hand side and the right hand side, as exponential expressions with the same base. But in this case, I have 1/4, right? So let's actually write it as a power of 2.
Oh wait, how do you know like what sides work with?
Well, which one's I can write 4 as a power of 2. I cannot write 2 as a power of 4. I can, but it would make it more complicated.
So you
Is
think
that,
the working with the left side would be better?
or the right hand side you want to rewrite?
Oh, the right hand.
Xavier,
Right.
Xavier,
Really?
you was right. Calculus was some bullshit. Xavier, you was right.
Hello, who is this? Xavier, do you know that guy?
I have no idea. I don't know what happened, but
Okay.
I didn't even say anything about this exponential function today. I just had like one questions, but I didn't say anything about bullshit or anything like that.
No, I understand. Sometimes actually I've seen this happen before also.
Okay.
So there was this Zoom bombing, and now there is Google Meet bombing or whatever. The point is, I don't know how they get this, how they got the link, because it's not available anywhere. Okay, so sorry about that, guys. Um, okay, so I'm gonna rewrite this in a different way. So I'm going to rewrite the right hand side like this. So first of all, let's write it as 1/4 to power x, right? And then I'm going to write it as, well, I can write it as 4 to power -x, or if you want, right? So I can write it as 4 to power -1 to power x. So that's just 4 to power -x. Okay, but then 4 I can write as 2 to power 2. So then the whole thing becomes, so this is 2 to power 2 -x, And this is multiply, this is not added, so this is important here. I don't add this to that, I multiply. Think of like I have parentheses here, right? So because this is to power, this is a power of the power. The power is negative x overall, but there is inside the power 2, so the powers multiply. So I get that this whole thing here, 1 over 4 to the x, is equal to 2 to power negative 2x. Okay? Just multiplying 2 and negative x. So what I got is that I get 2 to power x minus x squared, and that's equal to 2 to power negative 2x. Okay? And now all we have to do is just set the exponents equal to each other and solve. So this means that x minus x squared is equal to negative 2x. So if I solve this, I mean, I'm gonna add 2x to both sides. So I'm gonna write, so I have 3x minus x squared is equal to 0. So the solution is I can factor x out, and then I'll have 3 minus x equals to 0. So I have two solutions, x equals 0 or x equals 3. So those are my solutions. Okay? So whenever you have two exponential expressions which are equal to each other and the bases are the same, all you have to do is to rate that the exponents are the same and then solve the resulting equation. So okay, so I'm gonna stop here. This is all I wanted to say for today. These are some basic, I mean, as I said, it's gonna be a short lesson, but this is just a reminder of how to deal with exponential functions. Next time we'll go over logarithmic functions, and after that we'll deal with the compound interest. That's the reason we're doing this. Okay, do you guys have any questions?
So we're gonna have homework on this, right?
So as I said, there will be homework, but you don't have to do it. I'm not going to grade that. I mean, I'm not gonna count it. This
But
is just for you to practice.
it's not gonna have a due date. We can do it whenever we want.
The due date, I cannot do it after Friday next week, because that's when the final is, I assume. So yeah, so there's not going to be, just for you to practice, because on the final there will be an example. I hope to have an example of one compound interest problem.
Okay.
Okay, any other questions? Okay, I'm gonna stop recording then.